Ladies and gentlemen, welcome back to Amateur Repair Time. I have outdone myself this time. I went to an auction and online. I bid on some stuff online, and I was supposed to go pick the stuff up on Monday. This is a while back, and I forgot to go pick the stuff up. So and it's something minor. I can't even remember what it was. A box of records or something. And the guy is a real cool guy, and it's right down the road, not too far from my shop. And the guy emails me, he's like, "Hey man, you forgot to come by. I'll be around tomorrow though if you got time." And I was like, "Oh, sorry about that. I'll come by." So I swung by the next day, and the only person there was him and me, and I picked up my whatever it was. And as I was walking through his little shop where he's got all of his stuff stored from these auctions that he does, I saw some of this stuff. And I said, "Hey, what is this?" And he was like, "Man, that's some stuff that I auctioned off a couple months ago. And it's all so heavy that people either didn't bid on it because they had to ship it, or people bought it and then didn't pick it up, or people wanted me to take them apart and send them like little pieces off of it, like meters or knobs and stuff. And he didn't want to mess with it. He didn't want to take the time to do all that. So he just refunded the people the little tiny bit of money that they had bid on, whatever they had bid on. And then some of them didn't get any bid at all. So they were all just sitting there, and I said, well, what do you want for them?" Which I shouldn't have done. I shouldn't have even bought them, but I thought, you know what? Why not? They look pretty cool. And so he told me a very low amount. I don't want to say how much because I don't want to, let's just say these aren't worth very much, okay? So I hope everybody understands there's two things that you know about my videos, okay? One, it's called Amateur Repair Time for a reason. I have no clue what I'm doing with any of this stuff. Certainly not this. And two, I don't pay big money for anything. So if I've got everything in this room is cheap. Some of it might be worth a little bit, but it's just accidental. I don't even want it to be worth anything. I like the kind of normal stuff, right? I don't like the expensive stuff. I know a lot of people, they try to collect the really high-end radios and stuff. I'm not interested in that at all. I just like the normal stuff. There's nothing normal about this stuff though. So I don't even know what the stuff is. But I figured we'd go through it, and then I'm sure you'd all have plenty of comments, and you could tell me a little bit about it. And then maybe we can find a piece here that I can get to limp along and do something where we can tell if it does anything. So his opinion was he thought that the stuff was military. I don't think it's necessarily military. Maybe some of it. Maybe we'll find something on it to say that. I think it was just in some kind of lab somewhere. It's just old test equipment and stuff. So let's check it all out. Now this one piece on the very top is just an amp. That actually came from someone else. That didn't come with it. I just have it with this stuff because it's all similar vintage, So this is like a PA system or something. So it's a completely separate thing. I didn't get it as part of the deal. All right, so this says no bid on it. And it says that it is a Hewlett-Packard Distortion analyzer. I have no clue why you would need that. I don't know what you would be analyzing about the distortion. Maybe that would, let me think. I was watching something about Amelia Earhart a while back, and they were explaining the problem with her antennas. So if you haven't ever looked into that, if you're watching this video, you probably know a lot more about it than I do. But if you've never looked into that, basically Amelia Earhart, the reason that she didn't land, or at least didn't land where she was supposed to, is because she had radio problems. And there were, back then, the radio, one of the antennas broke, and then the other one was all right, but blah, blah, blah. So anyway, they mentioned whenever they were talking about that basically the way that the antenna worked was you would get a there were several different radio antennas and things that she could use, or that anybody could use back then. But there was one that was like a signal that was sent out, and you could kind of analyze it. They may have been saying that you could analyze the distortion of it to figure out the direction that it was coming from, or something like that. So maybe this was some kind of, maybe that was used for navigation or something. I don't know. I don't know why you would need to analyze distortion, but it could have something to do with radio. I don't know. So anyway, it's got a decibel meter. It says meter, distortion, set level, noise. This says balance. Oscilloscope, where you hook up a lead, I guess. RMS volts. Meter. Frequency. That is a hell of a dial. That's real. But that one isn't. That one's real easy to turn. That one's harder to turn. That's weird. AF and RF. Range. Times 1 times 10 times 100 times 1,000. And then I guess something was silk screened above it at some point somehow. AF input. And input minimum and maximum. All right, so I'm not going to be able to repair that one because I don't even know what it does, you know. I don't even know if there would be schematics for any of this stuff. I don't have any clue what that does. Most of it, though, is Hewlett-Packard. I've noticed that. So that is, and these two are the same vintage. They're actually, all three of those look like they're the same vintage. So wherever that was, these probably were. I think he told me that it's the same old story. A gentleman passed away. His wife had this stuff sitting around in the shed or something, and she gave it to him for the auction, and then he couldn't even get any bids on it, basically. Here, this is also Hewlett-Packard, and this is a wave analyzer, model 302A. What do you think about that? So again, a decibel meter, slightly different than the one on the other one. Range, volts. This stuff is just cool. Frequency. Look, it says fine. That is just, what a hell of a, just this, whatever this mechanism is here. I mean, whatever that mechanism is would cost probably $100 now just for that one little, the knob and the potentiometer or whatever they're using in there. Of course. Just amazing. Probably more now that I know that it has that 0 set. Okay. Power, AC only, on-off switch. Oh yeah, on-off switch on that one. Recorder, mode select AFC or BFO. That probably means something different now than it did back then. Output amplitude. Scale value, absolute, volts or dBm, or is that D8M? Relative, percentage or D8, dB. Percentage or dB. Is that decibel? Reference adjust. Yeah, okay, so up here there are two scales, RMS and decibels. So volts and decibels. Maximum input voltage. Caution. Ground the case. Make no attempt to measure the line voltage and input. All right, so let me tell you about this one. So wave analyzer, I don't know anything about it, and they're warning me that I don't know what the hell I'm doing. So I'm going to leave that one alone too. We're not going to fix that one. I wouldn't even know what it's supposed to do, okay? I'll tell you one thing though, they're not going in the damn trash, which was what was about to happen if I didn't buy them, all right? So I'll get them to somebody who knows what they're doing eventually. Another Hewlett-Packard. No bid. Think about how sad that is, okay? Nobody would bid on this. Look how freaking cool it is. What? What? Audio signal generator. Now this, that sounds like something I might be able to use for a radio, maybe. Only problem is, I don't know how to get the frequency to where I could, pick it up on a radio. So, decibel. So, my knowledge of decibels is how loud something is. 0.1 up to 1, so 0 up to 1. That, again, that switch has got to be worth some money if somebody was parting this crap out. Yeah. And then decibel 0 to 10. And range times 1 times 10 times 100. Power switch, off and on. 1.5 amp fuse. Well, I like that. If it's only a 1.5 amp fuse, it can't kill me too easy. Famous last words. Frequency, audio signal generator. Okay, so same thing. That's the fine tune. Well, that one's hard to move. Yeah, and that one's easier to move. So what are we looking at, though? I don't know. I don't know that I could use this on a radio. Well, I've got this. Okay, amplitude. So is that telling me? Let me think. So yeah, I use a little signal generator whenever I'm working on AM radios, but this isn't. Yeah, this is a signal generator. So amplitude, isn't that going to change basically the wave that it's sending out? I don't know, folks. Impedance, oh no. I'm bad about the impedance. 50, 150, 600, and 600 Gs. CT output. I would assume that says ground, maybe. That's a G, maybe. I don't know. Well, that one's possible. Maybe I might be able to figure out. So basically, if that does generate some kind of audio signal, I may be able to get it hooked up to a speaker or something, or a meter or something, where I can tell that it's actually generating an audio signal. Therefore, I could fix it. These I can't fix because I don't even know what to do. And then this one. Look at this bad boy. So this one's very heavy and has a big lid on the top that opens up, and it says, caution, high voltage inside. But it is also a Hewlett-Packard audio signal generator. And it says Palo Alto, California, just like the one above it. This is a model 205AG. which means I might be able to find some schematics or something. Now this one is a model 206A. So I guess this is the older version and this is the newer version. Let's see what we got. Output level, cool old Westinghouse meter. Look, Westinghouse and Hewlett-Packard in cahoots together. And that's going to show you your voltage. This is your input level. Okay, so on mine, you can change from a signal that it creates itself internally, or you can input a signal and it basically attaches it to a frequency that's broadcast, or comes out the probe so that you can use it on a radio. So I assume this one is probably, you have to use an input. I'll have to try to do a little reading on them. Input. This thing is just built literally like a tank. I can see why they would think it's military, just because it kind of has a military look. Input decibels. Power switch. Power light. Frequency range times 1 times 10 times 100. Okay, so I mean, if we're on 50 times 10, it's 500. The frequency is 500. But what's it measured in? And then if I get up to 200 here, and look at this. This has a clutch on it. You see this? Like, I'm turning it faster than that's turning. This is just high-level stuff. All right, so if I'm on 200 times 10, that's 2,000. So if that's kilohertz, that would be, I mean, you could pick that up as a AM radio station, couldn't you? You couldn't at 2,000, but you could at 1,200. I don't know what I'm doing. If it's hertz and not kilohertz, then we're way off. I don't know. Like I said, folks, amateur repair time. Look how it almost looks like that's just been made for it. I don't know. Load. Yeah, these aren't, none of these are identified, but these are. Kind of looks like it says volume. Impedance. Well, what do you think? All right, so moving right along. This is a beautiful beast here. It's a rack mount oscilloscope, and it's huge. I mean, the reason I have it sitting on there like that is because it's balanced like that. I don't want all that to fall over, and it's pretty balanced like that. It's a type RM502A dual beam oscilloscope. Tektronix. Look at that logo. That's the type of logo that they make now for like video games and stuff, whenever they want things to look retro and cool and, mid-century futuristic or whatever they call it. But that's a real one there. That's how it really did look back in the day. Pretty cool. So if you follow my arcade channel, you know that I ain't worth a damn on an oscilloscope, but I'm getting better. Time base, mode, normal, single sweep, reset. And this is freaking cool. The thing with these though is, so here's the deal with the oscilloscopes. All right, like I got one sitting right there. I actually do have several oscilloscopes because it's the type of thing when you see it, you go, wow, I could use that. And then you end up with 6 of them and you never use them. Trigger input, triggering level. My buddy Matt helped me set up the trigger on my oscilloscope, my digital oscilloscope on something a while back. Recurrent, slope, stability adjustment. Oh, wow. Sweep magnifier, on and uncalibrated, calibrated, variable, time, cm, milliseconds, mu seconds, trigger selector, external, AC or DC, or line, upper, AC or DC, lower, AC or DC. Yeah, I have no clue how to set any of that up. Maybe I'll learn. Horizontal display, sweep magnified. I kind of get that. Position, yep. Okay, so yeah, so on mine I've got this. So basically, you know, if you've got a wave on here, you're basically seeing how much of the wave are you looking at. So you can set it where it's like, you know, or you can set it where it's and position is like where on the wave you are. That's my layman's terms for it, folks. Yeah, welcome to another amateur repair class. Amplitude calibrator, off 0.5 megavolt or millivolt. Calibration out. Yeah, all of that I'm not going to be able to do. Okay, lower beam, vertical position, variable sensitivity. DC. Okay, I see. Lower beam and upper beam. So it can display 2 at the same time. So you can compare them. And the horizontal is basically how much of each you're seeing on the screen. I guess you got to do them both at the same time. All right. And then we've got upper focus, lower focus, intensity balance, power and scale illumination, horizontal deflection plate selector, time base or upper beam amplifier, amp. So it's a Tektronix RM502A dual beam oscilloscope. Tektronix Inc. Portland, Oregon, USA. Fantastic. All right, now, I got to prove to myself it's not going to bang me a good one on the head whenever I go down under this thing. That thing could kill me. Yeah, it's sturdy. Okay. Do you know what the bang you a good one thing is from? There was this book, I've mentioned it before in some of the videos. There was this book written by this hippie. It might have been the Power Supply hippie. About how to fix your Volkswagen Bug. And one of my friends had it back in high school, and he was always talking about how cool it was. Because the guy knew how to fix everything about a Volkswagen Bug. And one of the lines in there was something like, make sure you prop up the hood with a stick so it doesn't bang you a good one. That's where that came from. All right, so this is a wave analyzer, which is what this was. Wave analyzer. So this is a Hewlett-Packard 302A, and that's the same one. Also a Hewlett-Packard 302A, but it's set up slightly differently. Huh. Let's see what the differences are. I'm looking. Okay, this one has a damping knob, and this one does not. This one has a fuse on the front, but this one does not. And this one says external oscillator or normal, and this one doesn't have that. That's interesting. Why would that be? And this one is in a case. Oh, okay. Yeah, this one's in a case, and that one's a rack mount. But it could be that inside that case is that same rack mount faceplate. I don't know. They could have just built them like that. All right. And then this is a Hewlett-Packard 202A low frequency function generator. It says range 0.01, 0.1, 1, 10, or 100. So this is very fine tuning, but very hard to turn too. It might be screwed up. Triangular sine or square function, amplitude 0 through 100, sync out. You know, I was never trained in this stuff. I never went to school for this or anything. So a lot of these, I don't even know what they do. And, you know, we're at a time where you don't really need them for the stuff that I repair, at least. I'm sure they would help if you really knew how to use them. Voltmeter calibrator, model 738AR, Hewlett-Packard. Now, what is this? What does that mean? Maybe that, it says Calab. Is that some kind of initials? Maybe that's a sticker. And there was a laboratory that calibrated your stuff. That's what I'm going to guess. Or it could be just a laboratory in California where this thing was used. I'm going to guess that that's a sticker you got when you had the thing calibrated by that laboratory. Tracking function, calibrate multiplier, range in volts, output selector, internal calibration, this is a voltmeter calibrator. Yeah, I have no idea. I mean, I'm obviously it would be used to calibrate voltmeters, but how the hell would I ever know if it's working right or if I'm using it right? Okay, and then this one is maybe the most interesting of all of them. This looks like it's some kind of custom thing, and unfortunately, it's been parted out, so it's useless now. So that plate has nothing on it. Line voltage, AC regulated, AC unregulated, DC voltage, DC power meter scale selector. One amp slow blow, 1 1/4 amp slow blow, 1 amp slow blow, 1 amp slow blow, 2 amp slow blow. And it's in a, we got to make sure this doesn't bang me a good one. Look at this thing. Look at this. So unfortunately, like I said, they've started to part it out. And so there would have been probably some transformers and stuff mounted in there, or on the back of that actually somewhere. You can just see how nicely it was all routed, and they've just taken everything off of it. So it's of very little use now. But we have this. Date accepted, November 16th, 1964. So your guess is as good as mine. So I don't know what to do about that one. You know, that one does almost look military because it's painted green, and that's military. What do you think? All right, so I don't know if the guy knew if any of it was military or if he was just guessing or if that was just his idea. I would try to fix the oscilloscope, but I think it's more complex because it has the CRT and everything. But it would be easier to just get a beam on the screen to, you know, figure out if it was actually working. The wave analyzers, again, I don't know anything about those. The low frequency generator, I don't know anything about that. The voltmeter calibrator, I don't have any voltmeters to calibrate. The thing down there is parted. The distortion analyzer, it would need some kind of input signal to check, and I don't even know what I'm checking for. So I think it comes down to these two signal generators. I might be able to tell if there's some kind of signal coming out of with a radio or something. Or I guess I could hook a meter to it, or maybe even an oscilloscope to it or something, and see if there's a signal coming out. So if we're going to mess with those, I don't know. I kind of want to look at this big one. I think it's a little older, although it is a little custom. That Hewlett-Packard one, they're all Hewlett-Packard, but this one is just beautiful too. So I don't know. But I think we'll mess with this one. So let me unstack this stuff, and I'll get this up on the desk where we can mess with it a little bit. And we'll just look inside, and I don't know. Maybe we'll just give it a look and see how it looks, and try to bring the thing up on a Variac really slow and try to reform it and just see if it'll still do anything. Now, if you want a channel where the guy actually knows what he's doing with this stuff, go check out Mr. Carlson. I've never even heard of half of this stuff. He knows all about it, you know, so he could fix every one of these, I'm sure. But he wasn't here, and they were about to throw him away. So they came home with me. Yeah, so let me get that big, that's the heaviest one too. Let me get that thing out of there, and we'll take a closer look at it. Look at this beautiful thing. I can't figure out why they replaced the front. This has been redone. I don't know. Maybe it's just damaged or something. I don't know. So it's got a couple tags on it. Do not use for measurement, not on a calibration cycle. Okay. Do not use for measurement, not on a calibration cycle. And then it says, danger, hazardous voltages inside. Well, you know me. I don't know what... Okay, it looks pretty good. It's a little dusty, obviously. Let's see. Is that dust or is that... Actually, that's rust. And dust. I don't know, folks. This is completely out of my realm of expertise. I don't have much realms of expertise, but... I see one labeled 6HG down here. No, 6H6. That looks like just a light bulb. I don't know what was in that hole. The meters are hooked up. It looks like it's just been sitting a long time. Well, this is a much bigger rack case than the other ones. So I think it's like the rack mount thing. Like those. But just screwed into this big case. You can see how the sides don't even go all the way to the side. Yeah. Oh, okay, that's what's going on. Because it's not big enough. So there's the top, this plate. So it's because the case is different. Yeah, so this is original. I don't know what this is, why they did this. But this is just added to, it's just a filler plate to close up the box because they put it in a bigger case than it needs. Let me see under it. It weighs a ton. I mean, it probably weighs 80 pounds. It's that freaking heavy. 80 freaking pounds. That's my guesstimate, okay? Let me see if I can turn it up on its end, and let's see if we can see the capacitors and things underneath it, or if they're covered by that case. I just want to look at them before we actually try to bring it up. You know, I just want to make sure nothing looks damaged, obviously exploded, caught on fire, or something like that. All right, well, I was able to get it out of the case. Look at this case. I mean, I don't even... Just, this is all quality stuff, you know. It's a shame that they don't use a lot of this stuff anymore. I'm sure they probably do at some places, but... I got to tell you, I'm not going to go through and recap all this because I don't even know what it does, and it's such high quality stuff. I wouldn't be surprised if it still works just fine. I mean, these don't really... I don't like the looks of those, but I'm not going to go through and recap this. I might be able to find the schematic. So since it's Hewlett-Packard, look at the quality of these freaking resistors. Look at this. Look at this work of art here. Look at that. Look at that damn resistor. I don't know what the foam's for. A couple big caps under it. But you know, this is high level capacitry. I think it's made pretty well. Look at this thing. What a work of art. What is this? Is this a problem? Looks like it's just glue or something. Yeah, it's like it's the wax. I mean, it's amazing. Okay, so I think what I'm going to do is I'm going to slide it right back in there where it's been all these years and let it live there. And I'm going to, before I do, I think I'll spray some contact cleaner on these contacts, because I think that's probably the most likely thing, is that we'll have an intermittent connection on one of those switches. And then we'll put it on a variac and just bring it up real slow and watch the amperage, and just make sure it doesn't do anything crazy, and see what happens. That is a bulb. I'm sure it has a good use. Okay, so yeah, I'll slide it back. I'm gonna spray some contact cleaner and check this out. There's a potentiometer inside of it. I'm sure to calibrate something. Okay, so I'm going to leave that one alone just because I don't want to get it off calibration. There's more here. But the switches, I'll put some contact cleaner on, and I'm just going to slide it right back in, and then we'll hook it up and bring it up slow and see if we can tell if it's working. All right, so I put it back in there. The way I see it, you know, if it's going to catch on fire, I would rather it be in that case when it does it. Maybe I won't burn the house down. I have the fire extinguisher ready. It has a fuse in it, unless they've defeated it. I did see a fuse in the back. You saw that, right? Load on, okay. I've got it plugged into an amp meter, and then I've got the amp meter plugged into a variac, and then I've got the variac plugged in. I have all this over here on, the variac has a 2 amp fuse. This over here has a, it has a breaker. I think it's a 5 amp breaker, and I can easily turn it off. So, as long as it doesn't explode, we ought to be all right. And didn't it say it was 1.5 amp? Didn't we see 1.5 amp somewhere? Where would I have got that? Was it on the other one that said 1.5 amp? Okay, well, we're on 0 volts right now. So we'll turn it on. And so the idea is, if it starts causing problems, you will see the amps go up as it starts shorting and running juice through it. All right, so we're turned on at 0 volts. Hook! Did you hear something? It made a noise. Okay, so we're on. The lamp is not on because we were at 0 volts. So I'm going to turn it up to like 10 volts. And we'll see if we get any kind of movement at all out of this meter, which will help us understand if anything's even happening. There's something going on. All right, so I actually turned it up to 25. But it's all right. Don't worry about it. Look, folks, it's not going to kill me, or you wouldn't have been able to watch this video. If I uploaded the video, I must still be alive. So we're just going to let it sit here at 25 volts for a few minutes and let it kind of soak up some of that good AC voltage. I have this on the middle gauge here, or what do you call it? What is the word I'm looking for? You got one that goes up to 1 volt, and then the middle one goes up to 5 volts. I mean 2.5 amps. The small one goes up to 1 amp, the middle one goes up to 2.5 amps, and then the upper gauge goes up to 5 amps. So I have it set on the medium one. And we saw just a little bit of movement on the needle whenever we turned it on, which is just fine. If it's an 1.5 amp, we're going to be up here. It probably doesn't operate at that, or we would have, it wouldn't have that fuse on it. All right, so I'm going to turn down the input, because there's no input anyway. Frequency range, we'll just set it on ×1, and it's down on like 20. The volume is at 0. The load is turned on because I don't have any external load or output hooked up. The impedance I'm going to turn down to 50. Just, I don't even know if that matters with the load turned on. Decibels, we're going to turn it all the way down. Decibels all the way down. All right, let's give it a little more juice. Watch that needle. Tell me if anything crazy happens. Moving just a little bit. I would assume that those are the capacitors soaking up that sweet AC voltage that it hasn't seen in a very, very long time. I've heard differing opinions on this, on you know, what bringing it up slowly constitutes. See how it's bringing itself up slowly? I've heard people say that you can't reform a capacitor that quick. All right, so it's actually moving on its own, but I did turn it up a little bit. So we are at 60 volts. So I've heard people say that, you know, it actually takes a couple days to reform capacitors. So if that's true, doing it this way ain't really helping that much, but it's been effective for me. And I've seen other people talk about doing it for hours. I usually do it for like 30 minutes, if even that. So we're at essentially half voltage, and it's at, what's that, 0.6 or 0.55 maybe of an amp, 55 milliamps. All right, so I'm just going to let it sit like this for a while. I'm going to stay here with it, though, just in case it starts smoke rolling out of it or something. I just want to see if that's going to keep rising or if it's going to stay where it's at. So we do have some tube glow already. You can't really tell on the other ones. You know, I didn't mess with the sockets or anything. So it's been staying right where it is. If I mess with the output decibel knobs, the output meter has just moved around just slightly, where it looks like it's at least seeing something. Yeah, see it jumping just a little bit. Okay, so it's time to turn it up a little bit more. I think it's right about where it was. So we are at 65 volts. Okay, now we're at 80 volts. And at about 0.8 amps. I'm not so sure it's going to work, because you would think that you'd be getting some output, unless I just have no clue what I'm doing. You'd think you'd be getting some output, even at, you know, not the full voltage. I'm going to turn off the load switch just for a second and see what that does for us. Nothing. I'm going to turn it back on. No, I had a possibility too that it's got some bad tubes in it. All right, so I'm going to let it sit again for a little while at 85 volts. And or 80 volts, and let it just cook a little bit. All right, we're going to turn it up some more. All right, I think that's about 120. Looks cool to me. We are still at nothing on our output. I might have to test some tubes. Oh, there we go. I've had the volume down. I've tried it earlier when it was lower, but so these are decibels. 1 and then 100. I have no clue. 10 and 100. I have no clue how they're using it. So let's try the volume. Look at that. Holy crap. Now the input, I don't think will do anything because I don't have anything plugged in. Yep. Wow. Okay, so let's see what happens when we turn the decibels down, the 100 one. Okay, yeah, so the output level is just solely the volume, what they've got labeled as volume knob. All right, so let's mess with the frequency knob, see if that change. I guess that wouldn't change any of that. As it gets higher, it's going down a little bit. Let's do maths. So if these are hertz, 40, let's not do 40. Let's do, I can't even do 10. Let's do 20. 20 hertz. (200 hertz). It went down and back up. 200 hertz. 2,000 hertz. 20 times 100. I can hear it. Wow. So it's oscillating in the air. You can hear it. I don't know if you'll be able to hear it. The air conditioner's on right now, but if you listen, you can hear it. There's a like a going on. Let me see if it changes as I turn the knob. Yep. I hope you can hear that. I'm going to turn off the air conditioner so it's dead quiet, and then you can probably just hear it in the air. All right, so I've turned off the air conditioner. Oh, maybe if I turn the volume up too. Yep. The decibel ones aren't doing that. Okay, so I've got the volume pegged. So listen as I turn the dial and you'll hear the noise change. So that's 5,000 kilohertz. Six 6,000 kilohertz. 7,000. 8,000. 9,000. And I can't hear it anymore. So I lose the ability to hear it at about 98. What is it? 98, 9,800, 9.8 kilohertz. Is that right? 98 hertz times 100. 9,800 hertz. 9.8 kilohertz. I can still hear it a little bit. All right, well, it seems to be working fine. I think what I'll do is I'll bring home a scope from work. I've got these old ones here, but I don't. Ironically, what I need is sitting right there, and it may work, but that's a whole other project. I don't like just taking old stuff and plugging it in. I like doing it like we did this, looking at it, seeing how it appears, bringing it up slow, watching to make sure what happens, seeing if you can verify it somehow, you know. So I think what I'd like to do is hook it up to a scope. I've got a little digital scope that I can bring home and hook up to it and see if it would be interesting to see if it's anywhere near the right frequency that's indicated. This thing is loose as crap. I don't know. I don't know if I don't know how RF works. I don't know if this radiates out. I mean, if I'm hearing it, I guess it does, but I don't know how, I don't think I could pick it up with the radio because the radios are up too high, I believe. I don't think this goes up high enough. I wonder if it sounds different at 10. Can we hear it even at 10? Yeah, I can hear it. So that's 1,000. 90. No, 900. 800. 700. I can barely hear it at 600. I think my ears lose it between 500 and 600. Okay, yeah, let me get a scope and we'll hook it up to the output and try not to blow my scope up and see if it's anything like how it indicates. It's just wild that this stuff has been sitting around. Who knows? I would assume this was made in the 50s, maybe the 60s, but it kind of looks like the 50s to me. And still working, didn't do a thing to it. All right, so I've hooked the scope up to it. Kind of just to the best of my ability. And it looks like we've got 1.12 kilohertz. But we're set on 125, 1250 kilohertz. No, 1.250 kilohertz, 1.25, and we're at 1.15. So it needs calibrated, which may just be there. I saw a setting inside a adjustment which may calibrate it, but I don't want to mess with it. Let me see if I can. One of the things that's I don't get is the voltage. It's telling me that it's like a 2-volt swing, but it seems like it should be more than putting out more than 2 volts. Let me try to turn it up the decibel and see if what it. Oh, that's right. It said something about that this actually turns down the output. That's it. I read in the instructions or whatever. Not the instructions, but there's a manual online for it. All right, so that's 10 volts. Yeah, so it's basically, this lowers the voltage going out. That basically divides it, I guess. All right, so how cool is that? So if I change this, we're lowering the frequency. So we're down to 600.6, but we're at 520. So that's at 10. Let me do the let me mess with this. So that's got us at 55 hertz, but I'm set at 60. Let me look in the manual again and see if that is just as easy as changing that adjustment. So I'm talking about that. I wonder if that's a calibration adjustment. Okay, so it's a Hewlett-Packard 205AG, and mine isn't quite like this. It's set up a little different. So I think mine maybe is like an earlier version or something. And they're showing you these 2 capacitors here in the middle underneath the plate. This one and this one. We don't have either one of those. We have one over here. Turning that, though, adjusts the frequency just slightly. So I put it back where it was because it's a real fine-tune adjustment. And the second one's not there. I also have some on the very front on mine that are up here that are marked times 1, times 10, times 100. So they must be to calibrate something about the multiplier. There was that potentiometer underneath the chassis mounted to the side. That might be the missing one that we have here, but I'm not going to screw around with it. I don't really know for sure what it is, and I might screw up and start sending radio waves out that make planes wreck or something. Look, the thing works, it's just not, it needs calibrated. So that's the deal, right? So this is what it looks like with that cover off. Like I said, there's just the one adjustment to the side, and the other 2 it don't exist. And then it's hard to see, but down in there are 3 potentiometers that say times 1, times 10, times 100. So that's how she's made. And let me make sure that this is a 205. 205 AG. Didn't we think that it looked slightly different than the other one, though? we only had one. This is the 302 wave analyzer. What is this? .206A, so it's slightly different. This would have been the next model. All right, so there we go, folks. We've got the thing working by just plugging it in. But it's off a little bit. It also mentioned that the dial might be off, but if you look, it's actually dead on. See the little line? So it's at its physical limit where it's supposed to be. Why am I getting a headache all of a sudden? I'm just kidding. Pretty cool. All right, so there you go, folks. Tell me what you think. I'm sure you know a lot more about it than I do. Which one should I mess with? Probably the scope. I got to mess with the scope next. All right, I hope you enjoyed the video. I'll be back next week. We'll do something a little different, maybe a clock or something. But eventually I think maybe I'll figure out how to calibrate this thing where I can use it. I could set up a big rack over here on the wall. Every time I needed to do something, I could look important by going over and patching cables in and stuff. I'll think about it. All right, so if you like this kind of stuff where I don't know what I'm doing, check this out where I tried to mess with a voltmeter.